Question number 3. Consider the binary operation AND on the set 1, 2, 3, 4, 5 defined by A and B equal to minimum of the set AB. Write the operation table of the operation AND. So here we are having A and B equal to minimum of the set AB. So let's start filling the table here. 1 and 1, that means minimum of 1 and 1, that is 1. Minimum of 1 and 2 is 1. Minimum of 1 and 3 is 1. Minimum of 1 and 4 is 1. Minimum of 1 and 5 is 1. Now let us go in the next line. So minimum of 2 and 1 is 1. Minimum of 2 and 2, 2. Minimum of 2 and 3 is 2. Minimum of 2 and 4, 2. Minimum of 2 and 5, 2. Now third row, minimum of 3 and 1, 1. Minimum of 3 and 2, 2. Minimum of 3 and 3, that will be 3. Minimum of 3 and 4, that will be 3. Minimum of 3 and 5, that will be 3. Now fourth row, minimum of 4 and 1, that will be 1. Minimum of 4 and 2, 2. Minimum of 4 and 3, that is 3. Minimum of 4 and 4, 4. Minimum of 4 and 5, again 4. Now let us go in the fifth row. So minimum of 5 and 1, that is 1. Minimum 5 and 2, 2. Minimum 5 and 3, 3. Minimum 5 and 4, 4. And minimum 5 and 5 is 5. So this is the solution of question number third one. Question number 4. Consider a binary operation star on the set 1, 2, 3, 4, 5 given by the following multiplication table. In this we have to calculate first part, that is compute 2 star 3 star 4 and 2 star 3 star 4. Second part is star commutative. Third part, compute 2 star 3 star 4 star 5. So whenever we have to find A star B, A we have to take from the first column and B from the first row. So let's start finding this. First we'll solve the first part. So we have to find 2 star 3. 2 star 3, that means 2 will take from the first column. So 2 is here, then star is this, and 3. 2 star 3, you have to make a rectangle. So there are 3 endpoints already here, 2 star and 3, and the fourth endpoint will be our answer. So that is 1. So 2 star 3 will be 1, and then we have to find star 4. So this will be equal to 1 star 4. So again, now we'll go for 1 star 4. So this is 1 star 4, and the answer for this is 1. So 1 star 4 is 1. So equal to 1. Now let us find the value of 2 star 3 star 4. So whenever bracket is there, first we have to solve the bracket. So we will be finding now 2 star 3 star 4. So first we will find 3 star 4. So this is our 3 from the first column, star 4. So 3 star 4, if you make the rectangle, the endpoint will be 1. So our answer is 1. So equal to 2 star 1. Now let us again find the value of 2 star 1. So 2 star 1. So this is 2 star 1, and the answer is 1. So we are getting both the answer of 2 star 3 star 4 and 2 star 3 star 4 as 1. Now let us do second part. Second part, that is star commutative. If we say this is the main diagonal, so you can see we can see that the table is symmetric about the main diagonal. Therefore we say that star is commutative. So that is what we'll write. Since the table 1.2, since the table 1.2 is symmetric about the main diagonal, about the main diagonal, therefore star is commutative. Here you can we can easily see it that one is this aside, if you say on see on the both sides of this diagonal, here we are having one element, here also one. If we take two, then we have having here two. Similarly, if you take this one and if we fold along this one, then these numbers will coincide with each other. So they will get the same numbers. So therefore we say that it is symmetric. Therefore star is commutative. Now let us go in the third part. So third part, we have to compute 2 star 3 star 4 star 5. So whenever bracket is there, first we have to solve the bracket. So we'll solve 2 star 3, 2 star 3 star 4 star 5. We see from this table 2 star 3, 2 star 3. So the answer of 2 star 3 is 1. So let us write here 1 star. Then next we'll find the value of 4 star 5. So this is 4 star 5 and it is 1. And if we see again the table, 1 star 1 is 1. So this is the answer of question number 4. Question number 5. Let star dash be the binary operation on the set 1, 2, 3, 4, 5 defined by A star dash B equal to SCF of A and B. Is the operation star dash same as the operation star defined in exercise 4 above? Justify your answer. So here we are, it is defined A star dash B equal to as SCF of A and B, SCF of A and B. So let's start solving this table. So 1 star dash 1, that means SCF of 1 and 1 is 1. SCF 1 and 2 is 1. SCF 1 and 3 is 1. SCF 1 and 4 1. SCF 1 and 5 is 1. SCF 2 and 1 1. SCF 2 and 2 2. SCF 2 and 3 1. SCF 2 and 4, that is 2. SCF 2 and 5 1. Now let us go with 3 and 1. SCF 3 and 1 1. SCF 3 and 2 1. SCF of 3 and 3 3. SCF of 3 and 4 1. SCF of 3 and 5 1. Now let us go with 4 and 1. 4 star dash 1, that is SCF 4 and 1 is 1. SCF 4 and 2 2. SCF of 4 and 3 1. SCF 4 and 4 4. And SCF 4 and 5 1. Now let us go with the last row. So here 5 star dash 1, that means SCF 5 and 1 1. SCF 5 and 2 1. SCF 5 and 3 1. SCF 5 and 4 1. SCF 5 and 5 5. Now let us see whether both are identical or not. Suppose this table 1 and let this be table 2. So we can see that here the first row we are having star dash 1 2 3 4 5. Here also here if you see that star is 1 2 3 4 5. Then if we go in the next one, second row is 1 1 1 1. Here also we can see that third row is 2 1 2 1 2 1. Fourth row 3 1 1 3 1 1. Then fifth row is 4 1 2 1 4 1. That is same here also. And the sixth row 5 1 1 1, and here 4 times 1 is coming 5. Here also 5 and then 4 times 1 and then 5. So we can see that table 1 and table 2 are identical. So it is clear that table 1 and table 2, it is clear that table 1 and table 2, it's clear that table 1 and table 2 are identical. Table 2 are identical. And so therefore we can say that here it is asked that is the operation star dash same as the operation star. Therefore we can say that star and star dash are the same operation. Therefore star and star dash are the same operation, So this is the answer of question number 5th one. Question number 6th one. Let star be the binary operation on n given by A star B equal to LCM of A and B. Find the following. So first we do the first part. So here A star B is defined as LCM of A and B. And first part, So 5 star 7, that means LCM of 5 and 7, LCM of 5 and 7, and now both are prime numbers, therefore LCM will be equal to 5 into 7, that is 35. Now let us do the second part. 20 star 16, that means LCM of 20 and 16. So we will do the prime factors in 20. 20 is equal to 2 into 2, 4, 4 into 5 is 20. 16 is equal to 2 into 2, 4, 4 into 2, 8, 8 into 16. Now the common factors in both 20 and 16 are, this is 1, 2 and this is second 2. Therefore, LCM will be equal to 2 into 2, common will multiply only one time and with all the non-common ones, that is into 5. So into 5 into 2 into 2, and this will give us 4 into 5 is 20, 20 into 2 is 40, 40 into 2 is 80. So LCM is 80. Now let us go to the second part, is star commutative. Now what is A star B? A star B stands for LCM of A and B, A and B, and B star A is equal to LCM of B and A, and we can also rewrite it as equal to LCM of A and B. Therefore, we can say that A star B is same as B star A. Therefore, star is commutative. Now, let's go for the third part, is star associative. Here, A star B star C is equal to LCM of A star B, means LCM of A and B, A and B star C, that means equal to LCM of A and B and C. So let this be first one. Then we'll find the value of A star B star C. A star B star C equal to, that is LCM of A star, sorry, equal to, we write it as A star B star C stands for LCM of B and C, LCM of B and C, and now applying A star, LCM of B and C will get equal to LCM of A and B and C, A and B and C. Therefore, from 1 and 2, therefore from 1 and 2, therefore from 1 and 2, from 1 and 2, we can say that A star B star C is same as A star B star C. That means, therefore, star is associative. Associative. Now let us go in the fourth part, find the identity of star in n. We know that when we multiply two numbers, there is only the resultant of that two numbers will be one of the number only if one of the two numbers is 1. So definitely the identity of A star B equal to, that is A star B equal to A is suppose E is an identity, then A star equal to A is possible only if equal to 1. So that is what will apply here. Fourth part, let E be an identity, let E be an identity, let E be an identity for star, be an identity for star in n, for star in n, and let A belongs to n. Therefore, A star E equal to A, and E star A equal to A. Clearly, this is possible only if, clearly, this is possible only if n equal to, only if e equal to 1, only if e equal to 1, because we know that if you multiply 1 with any number, suppose we multiply 1 with 7, we get the answer as 7. If you multiply 1 with 3, we get the answer as 3. If you multiply 3 with 1, we get the answer as 3. So definitely the identity for star in this case will be 1. Now let us go into part 5. Part 5 is very simple one, because it says that which elements of n are invertible. We know that the product of two natural numbers is 1, only both of them are 1, and there are if any one of them is uh, not equal to 1, then definitely the product will not be 1. Suppose we take 7 and 1, then the product will be 7. If we take 7 and 3, the product will be 21. So the possibility of the product of two numbers being 1 is only if both of them are equal to 1. So definitely there is only one element which is invertible, that is 1 itself. So the answer of this will be which elements of n are invertible for the operation star. So there is only one element, that is 1. So that is what we'll write for the operation star. For the operation star, only one is invertible. Only one is invertible, because 1 star 1 is equal to 1, and there is no other number. If you multiply uh, any number is not equal to 1 with say any other element, which is with any element, even with 1 also will multiply, the answer will never be 1. That is the identity element. So that means there is only one element which is invertible, that is 1 itself. So this is the answer of question number 6th one. Question number 7 is star defined on the set 1, 2, 3, 4, 5 by A star B equal to LCM of A and B, a binary operation. Justify your answer. So here A star B is equal to LCM of A and B. So let us take say two numbers from the set A. Let it be say 4 and 5. So 4 star 5 is equal to LCM of 4 and 5, and 4 and 5 are co-prime numbers, so their LCM will be the multiplication of the two, equal to 4 into 5, that is equal to 20. But 20 does not belongs to the set A. So that means therefore we can say that does not belongs to A. That is A equal to the set 1, 2, 3, 4, 5. But we know that A star B is a the star is a binary operation only if A star B is also a member of the set A. So which is not the case here. Therefore we can say that star is not a binary operation. Therefore A star B does not belongs to A. Therefore star is not a binary operation. Star is not a binary operation. So this is the answer of question number 7th one. Question number 9. Let star be binary option the set Q of rational numbers as follows. And we have to check whether star is commutative or associative. So let us do the first part here. First part is A star B equal to A minus B. Now let us check whether it's commutative or not. To check if star is commutative. If star is commutative, so A star B is equal to A star B equal to A minus B is equal to then B star A is equal to B minus A, and we know that every time A minus B is not equal to B minus A. So therefore A star B is not equal to B star A. Therefore star is not commutative. Star is not commutative. Now let us check whether it's associative or not. So now we'll check whether star is associative or not. To check if star is associative or not. Associative or not. Now in this case we'll find A star B star C first. A star B star C. So that is A star B is here. We apply the definition, that is A minus B. Then star C equal to A minus B, and we have in A star B we are subtracting the second element from the first one. So A minus B star C will be A minus B minus C. Then we will find A star B star C. So first always we have to calculate the elements which are in the bracket. So we will solve for B star C. So equal to A star B star C is B minus C. Now A star B is A minus B. So now A star B minus C will be equal to A minus B minus C. You will keep in bracket, and that is A minus B plus C, and clearly 1 and 2 are not equal. Therefore from 1 and 2 we can say that star is not associative. Now similarly we can do the second one also. A star B is equal to A square plus B square. So what will be B star A? That will be B square plus A square, and A square plus B square is same as B square plus A square. So it will be commutative, and you will see that it will not be associative. And the same way you will try this this third part, fourth part, and this sixth part also. Fifth part is a very simple one. A star B is AB by 4. So B star A will be BA by 4, and we can write it as AB by 4. So it will be commutative, and it will be also associative. You can see that A star B, if you find A star B star C equal to, that will be AB by 4 star C, and that will give us AB by 4 into uh, C by 4, and that will be ABC by 16. Similarly, if you find this one, the other one, that is A star B star C, then in that we'll get A star B star C will be BC by 4, and then we'll get A star BC by 4 as equal to ABC by 16. So that means star will be in this case associative as well as commutative. So you will complete question number 9th one. Question number 10th one. Find which of the operations given above has the identity. Let's do the first part. So let E be an identity for star. Let E be an identity for star if possible. Be an identity for star if possible. And we know that if E is an identity, then A star E is equal to A, and E star A is also equal to A. Therefore, we will say that A star E equal to A minus E, where A belongs to Q, and this will give us, and we know that A star E, if it is an identity element, so it should be equal to A. So therefore A equal to A minus E, and this will give us, therefore E equal to 0. So now next let us find the value of E star A. So E star A is equal to A, and E star A means, if you apply the definition, we get E minus A. E minus A equal to A. Therefore we are getting E equal to 2A. So this is our second one. Therefore from 1 and 2 we can say that from 1 and 2 we can say that we have identity for star is not possible. Identity for star is not possible. Star is not possible. Even if we check here second one only here, because what we are having is 2a, and this 2a will value of e will go on changing if we change the value of a. Therefore, we can say that there is no identity element for star. It's very simple one. Now let us do question number 10, second part. A star b equal to a square plus b square. So second part, a star b is equal to a square plus b square. So let if possible E be an identity element. E be an identity element. Identity element for star. E be an identity element for star. Therefore, we'll get A star E equal to A, and also we'll get E star A equal to A. So let us first solve A star E. A star E equal to A. Now, A star E equal to A implies we'll apply the definition of A star B. So we'll be getting A square plus E square equal to A. Therefore, E square equal to A minus A square. Therefore, we'll get E equal to plus minus square root of A minus A square. Now here we can see that there are two values of E. There is one is plus and one is minus. Also, this A minus A square is not fixed because A is not a fixed number. We can take any value as A from the set of rational numbers. So that means here E is not a constant number. It is not a fixed number. That means there is no identity element for star. So that is what we'll write here. Since A is not fixed, fixed rational number, therefore the value of E will go on changing. Therefore, the value of E will go on changing here. The value of E will go on changing here. Therefore, that means E is not possible. Therefore, E as an identity element is not possible. E as an identity element is not possible. E as an identity element is not possible. Therefore, we can say that star has no identity element. Therefore, star has no identity element. So they are a very simple one, and this is how you will complete the remaining parts also. So you will not find any difficulty if you know the concept. Just let us recall the concept once more. So what is the concept? E is an identity element of star. If A star E is equal to A and E star A equal to A, and it should be noted that this E should be a constant fixed number. It should be a fixed number. It cannot be a variable. Suppose we have taken A from Q, then the value of E should be a constant number. It should not. We should not get the value of E in terms of A. So try this this 10th one remaining parts, and you'll find that it will not be at all difficult to you.